I took this image in 2023 during a Namibia vacation, and it was taken in the Namib Rand Desert in the area of the Tiras Mountains. Iconic dead trees are quite famous for Namibia, and the most famous area with such trees is the famous dead flea in the Sossusvlei National Park. This is not there, but it's almost as nice a landscape, and the skies in this place are among the darkest skies on Earth, and definitely the darkest skies I have ever seen in my life. The panorama spans about 225 degrees, and it shows the Milky Way arch, a setting Milky Way core above this beautiful landscape. If you have some time, I would like to invite you to join me on a little tour through the beautiful dark skies of Namibia. I'd like to start this tour in one of the most famous parts of the Milky Way. This is called Rho Ophiuchi, and it's the most colorful area in the sky. The red nebulas you can see here are hydrogen emission nebulas. These are interstellar hydrogen clouds that are ionized by hot and young stars and are thus glowing in the light of singly ionized hydrogen. The blue and yellow nebulas are so-called reflection nebulas. These are interstellar dust clouds that reflect the starlight from nearby stars. The blue nebula down here is Rho Ophiuchi nebula. It's quite a famous one, and it's reflecting the bluish light from its star. And in the center of the Rho Ophiuchi area, there's a yellow star. This is Antares, the main star of the Scorpius constellation, and the dust cloud around it reflects the yellowish starlight. So this area consists of red, blue, and yellow colors. That's why it's so colorful, and there are not many areas with all these colors. Another big hydrogen cloud is called the Cobalt Nebula, or the Zeta Ophiuchi Nebula, and this is obviously a nebula which is illuminated by the star Zeta Ophiuchi. The whole area is very close to the galactic center, the galactic core, which contains a supermassive black hole, and it is the densest part of the Milky Way, star-wise, and thus as well the brightest. It doesn't appear extremely bright because there are interstellar dust clouds, galactic molecular clouds, that block a lot of this starlight. That's why this area here is not as bright as it would be without these dark clouds. The area is also containing some more hydrogen emission nebulas. One of the famous, or the more famous ones, is called the Cat Paw Nebula, out of obvious reasons. Another famous one is the Lagoon Nebula, which can be seen here, and it lies next to the Trifid Nebula, which contains again a bluish reflection nebula and a red hydrogen emission nebula. Other famous emission nebulas in this area are the Omega Nebula or the Eagle Nebula. If we move further to the west, here we have a bright star cloud. This is the Scutum star cloud, and this is one of the brightest areas of the Milky Way, visible from Earth. If we move further to the west, it gets pretty dark. This is the big rift, the so-called Aquila rift, where these molecular clouds, these dust clouds, get much denser and block most of the starlight behind them. If we move even more to the right here, we get another cluster of these red emission nebula. This is Cygnus, constellation Cygnus, the swan, and in the center of these reddish clouds is the famous North American nebula. It's called North American nebula because it resembles the shape of North America, although here in the southern hemisphere it's standing on its head. Another part of this red stuff is the southern area to the left here of the North American nebula. Another interesting structure is slightly more to the north. This is the Wheel Nebula. This is a supernova remnant of a star that went supernova about 8,000 years ago. And the shell of material that's flying away from this supernova explosion is still glowing in red and bluish light. The bluish light here is not reflection that the starlight. This is actually ionized oxygen, while the red stuff is ionized hydrogen. If we move to the other side of the galactic core, we have two interesting stars. We see them here, the yellowish star on top and the bluish one a little bit below it. These are Alpha. The upper one is Alpha and the lower one is Beta Centauri. Alpha Centauri actually is a triple star system, and one of these three stars is called Proxima Centauri, and this is the closest star to our Sun. Closer to the horizon there's a dark cloud. This is the Coalsack Nebula, one of the darkest areas of the Milky Way. It doesn't appear that dark here because there's quite a bit of air glow along the horizon. And in this little mountain pass there's another red hydrogen emission nebula. This is the Lambda Centauri Nebula with a funny name, Running Chicken Nebula. As I said, along the horizon you can see quite a bit of light. This is not light pollution, this actually is natural airglow. This is ionized upper atmosphere molecules that reconnect with their electrons during the night and thus are emitting light. And this airglow is not always the same strength, and it appears brightest lower to the horizon because there we look with a shallow angle through the atmosphere. And this airglow also comes in waves, and you can see these waves very well on the right hand side of the tree. So now it's time to look a little bit farther away. All the structures I've presented so far are part of our home galaxy, the Milky Way. And the Milky Way is part of a group of galaxies that is called by astronomers the local group. It contains roughly 80 known members, and the biggest two of them are two huge spiral galaxies, one of them being the Milky Way and the other one the Andromeda galaxy. All the rest are so-called dwarf galaxy, although those dwarfs are pretty huge themselves as well. So let's see what we can find here. If we start on the far right of the image, we can actually see Andromeda galaxy. And Andromeda is the biggest member of our local group. It covers about twice the area of the Milky Way, although the Milky Way and Andromeda have more or less the same mass. It's 2.5 million light years away from us, and it's moving towards us at 120 kilometers a second, which means that the Andromeda Galaxy and the Milky Way will collide in about 4.5 billion years. So you do not just yet have to fasten your seatbelts. Huge spiral galaxies are often accompanied by dwarf galaxies, and Andromeda is no exception. And we can see one of these dwarf galaxy, it's called M110. It's an elliptical dwarf galaxy on the left-hand side of Andromeda's core. And this fuzzy dot there is actually the fifth largest member of our local group. The other dwarf galaxy we can see is inside the plane of the Andromeda galaxy, and it's this little fuzzy dot here. And it has quite an interesting history. It's called M32, and it once was a pretty large spiral galaxy, but it was cannibalized by the Andromeda galaxy, and everything that was left is the dense core of the former galaxy. All the rest of the stars were absorbed by Andromeda galaxy. And this little fuzzy dot contains a supermassive black hole, and the gravity of this black hole keeps the rest of this galaxy from being completely cannibalized by the Andromeda galaxy. If we move further to the right, we see another spiral galaxy. This is the Triangulum galaxy, M33. It's the third largest member of our local group, and it's another satellite galaxy of Andromeda. So if we move to the other side of the image, we can see some dwarf satellite galaxy of our own Milky Way. Let's start right here on the horizon. This is the large Magellanic Cloud. It's the fourth largest member of our local group, and it interacts strongly with the Milky Way, and this gravitational interaction is triggering intensive star formation in the large Magellanic Cloud. And these areas are easily seen as dots in the galaxy, and the biggest one of them is called the Tarantula Nebula on the bottom right here, and this is the most active star formation area in the whole local group. If we move up, we can find another fuzzy dwarf galaxy. This is an irregular dwarf galaxy, and this is the Small Magellanic Cloud, which actually is the sixth largest member of our local group. It contains 7 billion solar masses. And right above the Small Magellanic Cloud, there's a globular cluster. It's called 47 Tucani, and this globular cluster actually belongs to the Milky Way, but it lies roughly in the same direction as the Small Magellanic Cloud, which is about 15 times further away from us and 14,000 times more massive than 47 Tucani. The last stop of this little galactic tour is a small galaxy as well, an irregular dwarf galaxy, and it's called Barnard's Galaxy, or NGC 6822. It's about the same size as the Small Magellanic Cloud, but it's much further away, and that's why it's just a fuzzy dot here in the middle of the image. It's at a distance of 1.6 million light years, about 8 times farther away from us than the Small Magellanic Cloud, and it gives you an idea how the Small Magellanic Cloud would probably look when seen from the Andromeda Galaxy. So I hope you enjoyed this little tour, and feel free to leave me a comment of what you think of this kind of presenting an image. Thank you very much for your attention.